Hello and welcome to Algebra 1, Lesson 27. In this video, we're going to learn about integer exponents and the quotient rule. So in our last lesson, we learned about the power rules for exponents, and we also talked about the product rule for exponents. Now we're going to expand on this and start to learn about negative exponents, the power of 0, and then the quotient rule for exponents. So I want to start today's lesson out by just asking a simple question. What can we do if we see something like 2 to the power of 0 or 2 to the power of negative 3? If I have something like 2 to the 4th power, I know that this is 4 factors of 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Then if I decrease the exponent by 1 and I have 2 to the 3rd power, now I have 3 factors of 2, that's 8. If I have 2 squared, again, if I decrease the exponent by 1, I have only 2 factors of 2, or 4. And then I know that if I just have the number 2, that has an exponent that's understood to be 1, so that's just the number 2. So now I'm going to put 2 to the power of 0 here, and I'm just going to put question mark for right now. I'm also going to put 2 to the power of negative 1, and I'm going to put 2 to the power of negative 2. And let's see if we can use some basic reasoning to get some answers here. So the first question I would ask you is, do you notice any pattern here? Well, every time we increase our exponent by 1, you will notice that we take the result from the previous part and we multiply it by 2. So in other words, to get the answer for 2 squared, if I didn't know it, I could just take the result from 2 to the 1st power, and I could multiply it by another factor of 2, and I would get the result for 2 squared. So that would give me 4. What I could do, again, since I'm increasing my exponent by 1, I could just take this result, which is 4, and multiply it by another factor of 2. That would give me 8. Again, if I go up 1 in terms of my exponent, and I go to 2 to the 4th power, if I don't know what that is, I can just take 8, which is the result from the previous one, and again, multiply it by 2. 8 times 2 is 16. Now, that's obvious, because each time I increase my exponent by 1, I'm basically taking the previous answer and I'm multiplying by another factor of 2. What happens if I go down, though? Now I'm going to be dividing, right? The opposite of multiplication is division. So, in other words, let me kind of erase this real quick. If I start out at 2 to the 4th power, the exponent is 4. If I go down to 2 to the 3rd power, I've decreased my exponent by 1. So if I didn't know what any of these were, I could just start with 16 and say, okay, well, I have 16 here. I would just divide by 2, right? I'm just going to end up with the number 8, because essentially what I'm doing is I'm saying, okay, I had 2 to the 4th power, which is 2 times 2 times 2 times 2. And now I'm going to remove a factor of 2 because I'm decreasing my exponent by 1. So essentially, I'm dividing by 2 so that I can cancel one factor out. And now I have 2 cubed, which is this right here. So I'm dividing that previous result, which was 16, by 2, and now I'm going to get to 8. Now I'm going to get to 8. And I can keep doing this going all the way down. So in other words, if I want 2 squared, I take 8 and I divide it by 2, and I get to 4. If I want 2 to the 1st power, I take 4, I divide it by 2, and I get 2. If I want 2 to the power of 0, I take 2 and I divide it by 2 and I get 1. Okay, I get 1. This is 2 over 2 and this equals 1. If I want 2 to the power of negative 1, I take 1 and I divide it by 2. So that's 1 over 2, or 1/2. If I want 2 to the power of negative 2, I take 1/2 and I divide it by 2. So 1/2 divided by 2, or you can think of it as 1/2 divided by 2 over 1. And we know this equals 1/2 times 1/2, which equals 1/4. Let me show you another example real quick, and then I'm going to give you a few rules that you want to write down. Let's start out with a base of 3 and do the same thing. If I have 3 cubed, or you could say 3 to the 3rd power, we know this is 3 factors of 3, or 27. 3 times 3 is 9, 9 times 3 is 27. What about 3 squared? 3 times 3 is 9. What about 3 to the 1st power? we know that's 3. Then 3 to the power of 0. Let's do 3 to the power of -1 and 3 to the power of -2. Again, as I go from here to here, as I decrease the exponent by 1, I just divide this answer by the base. So in other words, if I erase all this, and I don't know any of it, if I want to go from a known result of 3 cubed, which is 27, to an unknown result of 3 squared, all I do is take the result here and divide by 3. 27 divided by 3 is 9. To get to here, 9 divided by 3 is 3. To get to here, 3 divided by 3 is 1. Again, 3 to the power of 0 is 1. To get to here, 3 to the power of -1. Okay, 1 divided by 3 is 1/3. To get to here, 1/3 divided by 3 is 1/9. So in each example, we saw 2 to the power of 0 was 1, and 3 to the power of 0 was 1 also. So here's the rule that you want to write down and memorize. Any non-zero real number that is raised to the power of 0 is 1. So a raised to the power of 0 is 1, and a is any real number, but a is not allowed to be 0. Okay, so a is not going to be 0. So any number you can pick, doesn't matter what it is. Let's say I have 1032. If I raise it to the power of 0, it is equal to 1. Because essentially what a to the power of 0 is it's a over a. It's the same number divided by itself, and we know that any non-zero number divided by itself is 1. So here are some very, very easy examples, and I'm sure you're going to see stuff like this in your textbook. So you have the number 168 raised to the power of 0. This is equal to 1. You have the amount -412, and this is inside of parentheses. So everything here is raised to the power of 0, and so this is equal to 1. And then you have the opposite of 8 raised to the power of 0. Again, remember this rule. So this is equal to -1 times 8 to the power of 0. 8 to the power of 0 is 1, so this is -1 times 1, which equals -1. Pay close attention to that, because for sure your teachers are going to try to trip you up with these. And then, of course, the same rules are going to apply when we work with variables. But again, you cannot raise 0 to the power of 0. So we have x, y. This is raised to the power of 0. It's inside of parentheses. So this is equal to x to the power of 0 times y to the power of 0. And each is going to be equal to 1. So you get 1 times 1, or just 1. But kind of the shortcut is to realize that, okay, both are raised to the power of 0. So this whole thing is raised to the power of 0. So that's just going to be equal to 1. And again, you're not going to see this at first, but recall that you can't divide by 0. And so x and y both have a limitation here. Neither one can be allowed to be equal to 0. Then what about something like z to the power of 0 y squared, and then this is all raised to the power of 0? Well, you don't need to go through anything. You could do it individually if you wanted to. You could do power to power rule and go, okay, well, z to the power of 0 times 0. And then this is multiplied by y to the power of 2 times 0. In the end, anything times 0 is just 0. So you can kind of skip this step because it ends up being z to the power of 0 times y to the power of 0, which just equals 1 times 1, or 1. But again, the shortcut is to realize that everything here inside the parentheses is raised to the power of 0, so the result is just going to be 1. So I could have just as easily said, okay, z to the power of 0, y squared. Everything's raised to the power of 0, so this just equals 1. All right, so for raising something to the power of 0, very, very simple. Remember, you raise any non-zero number to the power of 0, it's just 1. Okay, just memorize that. You're going to use that a lot moving forward. So now let's talk about negative exponents. So for negative exponents, we think about these using reciprocals. So I want you to recall that we had 2 to the power of -1, and this was equal to 1 over 2, or 1/2. We had 2 to the power of -2, and this was equal to 1/4. We saw 3 to the power of -1. This was equal to 1/3. We saw 3 to the power of -2. This was equal to 1 over 3 squared, or 1/9. Now, I'm going to give you the rule here. For any non-zero real number, a, Okay, a just stands for any non-zero real number. And any integer n, we have the following rule. So a raised to the power of negative n is going to be equal to 1 over a to the power of n. So you can just kind of substitute into this formula here, and you'll never get the wrong answer. So in other words, a here, in this specific example, is going to represent 2, right there. So then, all I would do is plug a 2 in where that is. So kind of to do this over here, I would have 1 over, plug a 2 in for a, and then here I see that I have negative n, and then here I have positive n. So in other words, this starts out as negative 1, it becomes positive 1, and 2 to the power of positive 1 is just 2. What we're doing here is we're taking the reciprocal of the base. So let's say I had something like 2 to the power of negative 3. I take the reciprocal of that guy, 2, and that's going to be 1 over 2, or 1/2. And then I'm raising 2 to the same exponent. The only difference is instead of it being negative, we make it positive. So 2 to the power of negative 3 is equal to 1 over 2 cubed. Or 2 to the power of negative 4 is equal to 1 over 2 to the 4th. Or 2 to the power of negative 12 is equal to 1 over 2 to the power of 12. It's not very complicated once you kind of memorize and do enough practice. Very, very straightforward rule. All right, so 4 to the power of negative 3. What do we do here? Flip the base, so this becomes 1/4. And then this exponent is now going to be positive. It's still on 4, but it's just now just going to be positive. So 4 to the power of negative 3 is equal to 1 over 4 to the power of 3, or 1 over 4 cubed. 6 to the power of negative 2. Again, flip the base. So 6 will now be 1/6. And then make that exponent positive. So this is going to be 2. So 1 over 6 squared. 4 to the power of negative 7. So again, flip that base 4. So this is going to be 1 over 4. And then your exponent here, instead of being negative 7, is positive 7. So this is 1 over 4 to the 7th power. What about x to the power of negative 3 y squared? Well, you can kind of separate these. Think about this as x to the power of negative 3 times y squared, like that. When you separate stuff with a multiplication sign, although you don't need it to imply multiplication, it kind of makes it easier for you to kind of separate these two in your mind. So this one right here is really 1 over x cubed, right? I have the base here, which is x. I take the reciprocal of that, so I get 1 over x. And then x is still going to be raised to a power. I just make that power positive. So instead of being raised to negative 3, it's positive 3. So really what this becomes is 1 over x cubed times y squared, which I can write as y squared over x cubed, right? Because y squared times 1 would just be y squared. So the next situation you're going to encounter is a negative exponent in the denominator. So what happens when your negative exponent is in the denominator? Well, all you really need to do is bring your denominator into the numerator and make the exponent positive. So I'm just going to take this guy up here, and the exponent's going to be positive. So 5 comes up here, the exponent negative 2 becomes positive 2, and this is times 1, which is still going to be 5 squared. So 1 over 5 to the power of negative 2 is just equal to 5 squared. And if you want to think about this using the rule that I just gave you, let's suppose we wrote this out. 1 over 5 to the power of negative 2. So let's say this is equal to 1 over 1 divided by 5 to the power of negative 2 is 1 over 5 to the power of 2, or 5 squared, right? Because this guy, we take the reciprocal. So that's 1 over 5. Make this guy positive, so raised to the power of 2. Now I wrote this original 1 here as 1 over 1 so we could divide with fractions. So how do I divide fractions? Again, this part would stay the same. So I'd have 1 over 1 times the reciprocal of this guy, which would be 5 squared over 1. At the end of the day, it's 1 times 5 squared, or 5 squared, over 1, which is just 5 squared. So again, the shortcut to that process is you're going to take the number from the denominator that's raised to a negative power, bring it into the numerator, and then you're going to take that exponent that's negative, and you're going to make it positive. Let's say I came across a problem like 3 to the power of negative 3 over 5 to the power of negative 3. So what is this equal to? So the shortcut is to take what's in the numerator here, bring it into the denominator. So 3 goes into the denominator. Instead of the exponent being negative, it's now going to be positive. And then this 5 here is in the denominator, bring it into the numerator. Instead of the exponent being negative, make it positive. So this becomes 5 cubed over 3 cubed, or I could write it as 5 over 3, that amount cubed. Now, if you want to go about it the slow way, you can certainly do that. So 3 to the power of negative 3 is 1 over 3 cubed. And this is over, we have 5 to the power of negative 3, which is 1 over 5 cubed. We know how to divide fractions. The first one stayed the same, so 1 over 3 cubed. We're going to multiply this by the reciprocal of 1 over 5 cubed, which is 5 cubed over 1. Of course, we get 5 cubed over 3 cubed. So that leads us to this little simple rule here. If we have a negative exponent, move the base across the fraction bar and change the sign of the exponent. So in more mathy terms, for any non-zero real numbers a and b and any integers m and n, we can set up this a to the power of negative m over b to the power of negative n is going to be equal to, I would take this b and bring it into the numerator and raise it to a positive n, put it over a, which is going to go into the denominator, and raise it to a positive m. So as an example, let's say I had something like, I don't know, 3 to the power of negative 6 over 2 to the power of negative 7. All I need to do is take 2, bring it into the numerator, and make the exponent positive. So this is 2 to the 7th up here. Take 3, bring it into the denominator, make the exponent positive. So this would be 2 to the 7th over 3 to the 6th. So again, if we have a negative exponent, move the base across the fraction bar. So that's why I move this 2 across the fraction bar. So from the denominator into the numerator. See how it crosses above the fraction bar. And then you just change the sign of the exponent. So it was negative, and now it's positive. I did the same thing here. I dragged this below the fraction bar. It was negative, and now it's positive. So let's look at some quick examples here. We have 4/7, and this is raised to negative 1. So using our rules from our last lesson, we know we can write this as 4 to the power of negative 1 over 7 to the power of negative 1. And then what we just learned is we can take this 4 and drag it down here, raise it to the power of positive 1. We can take this 7 and drag it up here, raise it to the power of positive 1. So this is 7 over 4. It's just 7/4. And the same goes when you're working with some variables. So for y to the power of negative 3 over x to the power of negative 2, this variable x is going to come up into the numerator, and I'm going to now raise it to positive 2. So that's x squared now. This y is going to go into the denominator, and I'm going to raise it to positive 3. So I get x squared over y cubed. Okay, so now let's talk about the last rule that we're going to learn, and it's known as the quotient rule for exponents. So I want you to suppose that you need to simplify something like 8 to the 7th power over 8 to the 4th power. So with the knowledge we already have learned, we could take 8 to the 7th power and write it as 8 times 8 times 8 times 8 times 8 times 8 times 8. This over 8 times 8 times 8 times 8. All right, we can cancel common factors between numerator and denominator. We cancel this with this, this with this, this with this, and this with this, and I'm left with 3 factors of 8, or 8 to the 3rd power. But how can we do this more quickly? Well, I can realize that the exponent that I have right here in the top minus the exponent that I have right here on the bottom gave me the ending exponent. So I could have started out with saying, okay, I have 7 factors of 8, and I'm going to be canceling away 4 factors of 8. So that's going to leave me with 7 minus 4, or 3 factors of 8. So if I saw something like 7 to the 9th power over 7 to the 5th power, you guessed it. I can take this number right here, this 9, and I can subtract away this number right here, this 5, and I would get 7 to the 4th power, right? And to see that once more, again, if I write out 9 factors of 7, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 5 factors. 1, 2, 3, 4, 5. What's going to happen is I'm going to end up canceling 5 factors of 7 here. In other words, if I think about this using the exponents, I'm starting out with 9 and I'm subtracting away 5. I'm going to end up with 4. Right? Cancel this, cancel this, cancel this, cancel this, and cancel this. This is what I'm left with. I'm left with 4 factors of 7, or 7 to the 4th power. So this leads us to the following rule. For any non-zero real number a and any integers m and n, we want to keep the base the same and subtract m minus n. So in other words, if I have the same base here, the same non-zero real number, and they're involved in a division that looks like this, all I need to do is keep the base the same. So I would keep a the same, and I would subtract the exponents. I would take the 1 in the numerator, which is m, and I would subtract away the 1 in the denominator, which is n. So for 5/9 over 5 cubed, again, this is the same base, so I write 5. So I take my exponent in the numerator, which is 9, and I subtract away my exponent in the denominator, which is 3. And 9 minus 3 is 6, so this is 5 to the 6th power. And again, you can prove that to yourself. You can write out 9 factors of 5, and then underneath, you can write out 3 factors of 5. And you can cancel 3 factors of 5 away from the problem you create there, and you're going to end up with 6 factors of 5, which again is our result. All right, here we have x to the 4th power y cubed over x squared y. So for x to the 4th power over x squared, I would keep the base x the same. Then I would subtract exponents. So I would take the exponent in the numerator, which is 4, subtract away the exponent in the denominator, which is 2, and then I have y cubed over y. So I'm going to put y down, keep the base the same, and then I'll have 3 minus, this exponent will be 1. So 3 minus 1, so this equals x squared, 4 minus 2 is 2, times y squared also. 3 minus 1 is 2. So you could write x squared y squared, or you could write xy, this inside of parentheses, squared. So even when negative exponents are involved, we follow the same rules. So we have 7 to the power of negative 4 over 7 cubed. So what I'm going to do is I'm going to keep that base 7 the same, and then I'm going to subtract the exponent in the numerator, which is negative 4, minus the exponent in the denominator, which is 3. So this gives me 7 to the power of negative 4 minus 3, which is 7 to the power of negative 7, which we write as 1 over 7 to the 7th power. All right, let's take a look at some practice problems to kind of wrap up the lesson. So we have xy squared. This is in parentheses, and it's raised to the power of negative 2. Then this is over. We have negative 2 times x y cubed times negative 2 times x to the power of negative 1. So let's start out in the numerator. Let's use our power to power rule to simplify. So we have x raised to the power of negative 2. So that's x to the power of negative 2. And then we have y squared, that's raised to the power of negative 2. So y stays the same. We multiply the exponents. 2 times negative 2 is negative 4. In the denominator, I have a negative 2. I have an x. I have a y cubed. And I'm multiplying this by another negative 2. An x raised to the power of negative 1. Now, before I simplify any further between numerator and denominator, let me simplify this denominator here. Let me just erase this and make a new line. So negative 2 times negative 2 is 4, or if you want to kind of keep with the spirit of exponents, I could write negative 2 inside of parentheses squared like that. Then I have x y cubed, and we're multiplying this by x raised to the power of negative 1. Now, this can be combined with this. X to the power of 1 times x to the power of negative 1 is what? Well, remember, x to the power of negative 1 is 1 over x to the first power. So really, what this becomes is x over x, which is 1. And you can verify this using your product rule for exponents. This is x to the first power times x to the power of negative 1. Well, this is x to the power of 1 plus negative 1, which equals x to the power of 0, which by definition is 1. So essentially, these two would cancel out. You could just erase them. So I'm just left with this -2 inside of parentheses squared, which I'm just going to go ahead and write as 4, times y cubed. Now, to simplify this further, in the numerator, I have x to the power of -2, and then I have y to the power of -4. Now to simplify, I have a y cubed down here. So again, the quotient rule for exponents tells me that same base, I can take that base, keep it the same, which is y, and then I can subtract, take the exponent in the numerator, which is -4, subtract away the exponent in the denominator, which is 3. So then this is over 4. And this equals x to the power of -2 times y raised to the power of -4 minus 3, which is -7. This is over 4. So this is going to be equal to, these are both going to get moved down into the denominator. So I'm going to write the numerator as a 1. This guy right here, again, like I just said, is going to come down here, and so is this guy. So I have my 4, that's going to stay the same. So when I drag this below the fraction bar, the x stays the same, but then the exponent is going to go from negative to positive. Then the y is going to go down there. The exponent goes from negative to positive. And because these two both went down there, I'm going to write a 1 as my numerator. What about something like x squared y cubed times 2x squared y to the power of -2 over y to the power of -2, and then everything's inside of brackets and it's raised to the power of 0. Well, the shortcut here is to remember that everything is raised to the power of 0 here. Anything raised to the power of 0 is 1. So you see that on a test, you just put 1. But you can go through it and do the power to power rule for everything. What's going to happen is every single thing in here is going to end up being raised to the power of 0. So you'll just have 1 times 1 times 1 times 1, a bunch of 1s being multiplied by itself. And then down here it'd be over 1, so you'd end up with just the number 1.